Hi, welcome to the Olympiad geometry. Let's continue our study on Excenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Here is a problem. Circle I is inscribed circle for quadrilateral ABCD. BA and CD meet on E. AD and BC meet on F. Let angle BEC equal to alpha. Let angle AFB equals to beta. Prove that AD times BC divided by AB times CD equals to cosine square half alpha to cosine square of half beta. So for this problem, the first thing that we should notice is that circle I is excenter of triangle EBC and triangle FCD, right? And also it's incenter of triangle AED and triangle ABF, right? So if you look at AD times BC to AB times CD, AD times BC, that is difficult to get, right? So we must break this to other form, like AD to AB times BC to CD, or AD to CD times BC to AB, right? So think about that. If we want to put AD and CD together, then we have to understand that if we put AD and CD together, the only thing that we can get from AD to CD is the sine angle ACD to sine angle CAD, right? But we don't have any knowledge about the angle CAD, right? It's difficult to get. So maybe the figure doesn't look like a very clear figure, but I want to make sure that the audience should understand that AIC are not collinear, right? So it can be, right, but not necessary to be a collinear. So, but AI is a angle bisector of angle BAD, right? Similarly, CI is an angle bisector of angle BCD, right? And this is angle bisector because what? Because the distance from I to AB and AD are equal, right? Also similarly for BI and DI are all the angle bisector of angle ABC and ADC, right? So based on this, we know that if we connect or we put the ADCD together, we get nothing. If we put the AD and AB together, AD to AB, then we can get something AD to AB, right? Because look at the triangle AIB and the triangle AID. The altitude are the same, right? The altitude for HAB in triangle AIB is this one. The distance from I to its projection on AB, right? That's the altitude, and that equals to the radius of the circle I. Similarly, for ADI, the altitude is also the radius of the circle I, which means AD to AB equals to the area of triangle AID to area of triangle AIB, which can be rewritten as half of AI times ID times sine angle AID to half of AI times IB times sine angle AIB, right? And AI and 0.5 cancel each other, so we have ID to IB left times sine angle AID to sine angle AIB. What is AID? Because IA is the incenter of triangle AED, so angle AID is 90-degree plus alpha, right? That's a property we learned from the incenter. If you don't remember this one, please refer to the previous video. Talk about the properties of the incenter, right? So angle AID equals to 90-degree plus alpha, right? It's very easy to prove, right? Because alpha plus this angle is 180 degree. So this one plus this one is 90 degree minus half of alpha, right? So this angle equals to 90 degree plus half of alpha. And for the same reason, the angle AIB, because I is in center of the triangle AFB, so angle AIB is 90 degree plus half of beta, right? AIB is 90 degree plus half of beta. Okay, so sine 90 plus half of alpha, that is cosine half of alpha, right? So equals to ID to IB, cosine half of alpha, cosine half of beta. We're close. So what about BC to CD? BC to CD equals to the area of triangle BIC to the area of triangle CID, which is half of BI times IC times sine angle BIC to half of CI times ID times sine angle CID, right? So equals to BI to ID times angle BIC, because I is excenter of triangle EBC, so angle BIC equals to 90 degree minus half of alpha, right? This is a property of the excenter. Please review the excenter property video before. So for the angle CID, that is 90 degree minus half beta, right? So sine 90 degree minus half of beta, right? So that's actually cosine half alpha, cosine half beta, so it equals to BI to ID, cosine half alpha, cosine half beta, right? So if we multiply them together, we get AD to AB times BC to CD equals to cosine square half alpha to cosine square half beta. Okay? So for this problem, it's a immediate level difficulty problem. It's the main, the break point of this problem is circle I. Because circle I is so unique, right? It's an incenter of triangle AED and the triangle AFD. It's excenter of triangle BEC and triangle CFD. All of them relates to the angle bisector line. That means we need to directly think of to connect all the angle bisector lines, right? Connected to I, and get all the angle bisect lines, and then based on that to solve the problem. Okay, that's it. I hope you like this video. See you in next one. Thank you.